Hello, ladies and gents, Mr. D'Souza here. So remember, this is going to be your homework number 12. It's going to be an unlisted video, so the only way that you could have seen this video is if you clicked the link on Google Classroom. So thank you for doing that. This homework is all about you correcting the work that you did in class, so make sure that you're editing your work as we go through all 4 stations. So let's get to it. The first thing I want to quickly go through is your problem-solving planner. With the questions that we have been doing, this is a very helpful and useful tool that you can use when trying to solve problems. So these are the 4 questions that should be running through your head when you're trying to solve problems. You should be able to know what the question is, what information does the question give you, how does the question connect to what you're learning in class or what you've learned in class, what is your plan of action, and what will your answer look like, and then you should be able to solve the problem. So we're going to try to use all these 5 things. Let's jump to it. So the first one, station A. Remember, this has to do with all about parallelograms. So I have the main properties of parallelograms up here, and let's jump into it. In the diagram of parallelogram FRED shown below, line segment ED is extended to A, and AF is drawn such that AF is congruent to DF. This looks like it's very, very, very important. So, couple of things. The question's asking us, well, if the measure of R is 124 degrees, what is the measure of AFD? So I know my answer has to be the measure of angle AFD is equal to something. It gives me a bunch of information. So AF, here's AF, is congruent to DF. Ooh, that's interesting. And then it tells us that the measure of angle R is 124 degrees. So here's angle R, and this is 124 degrees. Now, a couple of things. Before I even look at this parallelogram, just based off the information that they gave us, check this out. What type of triangle is FAD? It's isosceles. So if it's isosceles, that means the angles opposite the congruent sides must be congruent. Bam. Alright, so let's jump to it. It asks us to find the measure of AFD. That happens to be this. So I'm going to put an X right here. Somehow I'm going to have to get this angle. Okay? But we're starting here. We're starting with an angle. So I'm going to look at these properties and figure out which property is going to help me determine, or rather get any other information about this picture. So this is an angle, so I'm not going to talk about opposite sides being parallel. That kind of helps, but not really in this case. Both pairs of opposite sides are congruent. I don't care about sides. Both pairs of opposite angles are congruent. That's important because the opposite angle of angle R is this angle right here. So if this is 124 degrees, then this is 124 degrees. All right? Now, again, I kind of want to follow my nose. What else can I do with 124? Well, this angle and this angle forms a linear pair. So 180 minus 124 is 56. So this must be 56 degrees. But if this is 56, this also must be 56 because this is an isosceles triangle. And wait a minute. Triangle sum theorem. I can get the last angle in a triangle. So I can do 56 plus 56 plus something is 180. 56 plus 56 is 112. So 112 plus x equals 180. Subtract from both sides. 180 minus 112 is 68. So x equals 68. So the measure of AFD must be 68 degrees. All right. Next one, in parallelogram QRST shown below, diagonals TR is drawn to U and V and points TS and QR respectively. And UV intersects at TR at W. And then they give us a bunch of information. The measure of angle S is 60. The measure of angle SRT is 83 degrees. And the measure of TWU is 35. What is the measure of WVQ? So, my answer is going to look like this. The measure of angle WVQ equals something. All right. So let's check this out. Let's just start filling in some information. If you notice, this happened to have been a question on your checkpoint quiz a very long time ago, only we didn't give you all of this information on top because you didn't know what a parallelogram is. But essentially, we're going to solve this the same way. So let's fill in some information. Angle S is 60 degrees. We actually might be able to do this a little bit easier. SRT is 83, so SRT is 83 degrees, right? And then TWU, so TWU is 35. So this little guy over here is 35 degrees. So we want to find WVQ. So WVQ, that's this angle. So WVQ. So we're looking for this angle. Okay? There's a lot of ways that you can do this question. But I'm going to show you one way. And it would be really cool if you found another way. So let's highlight a couple of things. Check this out. Whoop, that is a little bit too big. Let's try this. So if I highlight, that was pretty gross. Let's try that again. If I highlight this shape, sometimes you gotta be clever with these problems. What kind of shape is that? Well, we know that that is a triangle, and they give us two angles of a triangle. So if I want to find the third angle of a triangle, what I can do is I can add up 60 plus 83 and subtract that from 180. And then you get 37 degrees. So this plus this, 180 minus the sum of that, is this angle, and that is 37 degrees. Now, I didn't even talk about anything to do with a parallelogram yet. Okay? I'm still going to fill in more information just based on what I see. If this is 35 degrees, this also must be 35 degrees because these are vertical angles. So now I'm kind of stuck. Do you notice that I'm starting to get closer to the angle I'm looking for? All right. So let's see if there's other things that we can do. So we can look at some of the parallelogram properties, and since we're working with angles, we can talk about opposite angles being congruent. So if this is 60, this angle, is that Q? Yeah, angle Q must be 60. However, that's not going to necessarily help us. It could. It actually could get us to the answer, but it's a longer way. So if you can figure out if this is angle 60, if you could show me another way to do this, that would be super cool. But I want to try to find the easiest way. So I'm going to talk about both opposite sides being parallel. So remember, when we talk about sides being parallel, remember a little trick that we showed you is you can highlight it and then highlight the transversal. Do you notice any angles that are now congruent? So check out the angles that this Z makes. If this is 37, then this angle must be 37 degrees. And why is that? Because that, or rather those, are alternate interior angles. Okay? But check this out. I'm going to take this shape, and I'm going to redraw it over here. Okay, I want to show you something pretty interesting. So, this was 35 degrees. This was 37 degrees, and we're looking for this. Now, there's two ways you can do it. One way, you can find this angle using the triangle sum theorem, and then subtracting it from 180 to get this angle via linear pair. Or you can notice, hey, this is an exterior angle. If I add the two remote interior angles, it equals this angle. So on my calculator, I'm going to do 37 plus 35, and I get 72 degrees. So this angle happens to be 72 degrees. All right, let's move on. So this one happens to be very similar to something that we just did. So I'm going to kind of go through this relatively a little bit more faster, or a little bit more fast. So it gives us information. This is a parallelogram. It talks about AB is extended through B to E, and CE is drawn. All right, if CE is congruent to BE, and the measure of angle D is 112 degrees, what is the measure of angle E? So this happens to be the same exact setup as this question, only you'll notice that this triangle, this isosceles triangle, is on its side. So we need to be very careful. So we already acknowledged, let me use a different color. We already acknowledged that this is an isosceles triangle, so if this is congruent to this, these two angles must be congruent, because that's by definition of an isosceles triangle. And let's just jump to it. If this is 112 degrees, remember opposite angles in parallelograms are congruent. So if this is 112, this is also 112. By a linear pair, if I want to find this angle over here, I can do 180 minus 112, and I get 68 degrees. 68 degrees. But if this is 68, this is also 68. And if I want to find the third angle of a triangle, I can just add it up. So 68 plus 68 plus x equals 180. So 68 plus 68, that's 136. And then I can subtract 136 on both sides. And you're left with x equals, so 180 minus 136. That the measure of angle E is 44 degrees. Very similar to the other one. It's actually the same process as the other. You just got to be very careful with the picture. All right, last but not least. In diagram below of parallelogram ROCK, the measure of angle C is 70. Oh, wow, they actually put it in for us. And the measure of angle ROS is 65. Okay, what is the measure of KSO? So my answer, I'm going to use a different color. My answer has to look like this. The measure of angle KSO is something in degrees, right? Where is the measure of angle KSO? So KSO is this angle. We need to find this angle. So let's just use some parallelogram properties. Let's check this out. So they give us this angle. This is not really helping us because this is like part of the part of one of the angles, but they do give us 70. And we know opposite angles in parallelograms are congruent. So if that's 70, this must be 70. And now, can't I find this angle? We can do 65 plus 70 plus something is 180. Right? Isn't this a triangle? And if I want to find the third angle of a triangle, I can add these up and subtract from 180. So 70 plus 65 is 135, and 180 minus that is 45 degrees. So this happens to be, let me write in a different color, this happens to be 45 degrees. But we're not done, because we're trying to find angle X. So 45 degrees plus what? So 45 degrees plus X is 180. That means we can do 180 minus 45, and you get 135. So the measure of KSO is 135 degrees. So if you got any of these answers correct, but you did it a different way, that is awesome. Most of these questions you can do many different ways. And if you noticed, most of the ones that we used were the following: that opposite sides are parallel and opposite angles are congruent. The other properties are important, but mostly they come up in other topics in geometry that we're going to explore in a couple of months. Okay? Last but not least, make sure that you made all of your corrections, and I hope you have a great rest of your day. Bye-bye, guys.